Today we will discuss some different types of mean averages. In the previous class, we have discussed arithmetic mean and a simple average, weighted average mean. In addition to that, mean, mode, and median. Arithmetic mean, it's mean we get the total of the observation and divided by number of observation. It is called arithmetic mean. Simply we call them as arithmetic mean. This is arithmetic mean, right? So it has some sort of a linear relationship, right? It has no much variations across the observation. So that we can use arithmetic mean. Arithmetic mean, sum of all observation divided by number of observation. That's arithmetic mean. This arithmetic mean can be applied in many scenarios in our day-to-day incidents. But there are some occasions where application of arithmetic mean may mislead our conclusion about their data set. So that there are some different means we can use, such as geometric mean, to measure, to find out the average growth. And we may use harmonic mean to find out the rates. We will discuss that instances. The mean, median, and mode assume data behaves linearly. Linear mean there is some arithmetic progression. Arithmetic progression. But when the data multiplies, compound, or involves rates, simple addition fails, right? So in the case of multiples, like the progression is like this: 2 by 2, right? First observation 2, second observation 4, second observation 8, then 16. So in these instances, we can't use arithmetic mean. So it grows, right? It grows very fast, right? And rates, right? Here, sometimes it goes up and down, right? In this behavior, we may use harmonic mean. Involves rates, right? So just to use arithmetic mean may not help. Geometric mean, the specialist growth and ratios. Let's see, we see the PDF. In addition to three measures, mean, median, and mode, we sometimes use following measures as measure of central location. Already we have discussed, these are the ways of calculating central location. In addition to that, there are two, right? Geometric mean and harmonic mean. Here, the set of numbers, we have x1, x2, right, x3, like that. So it goes until xn. Geometric mean is given by, in this formula, right? We put all the observation, and in between there will be multiplication, right? Multiplication, and we have to find out the root of number of observation. So why why do we need this kind of geometric mean? Why arithmetic mean may not possible, right? Let me give one example to you all to find why it does not support always. Why arithmetic mean does not support all the instances. For example, see this stock price, share price. in 2020, the share price would be 100 rupees. And share price in 2021, the share price is 150. And again, in 2022, the share price became 100. Share price became 100. This is price. Now let's discuss. Let us find the profit or rate of return. Rate of return. Before that, we find profit. Profit and return. Return. Right? Return. Rate. Return rate. Rate of return or return rate. Let's see. Here in 2020, we purchased the stock. So no profit, no loss this period. And we sell this stock for 150 so that the profit is 50 rupees. This 50 rupees is achieved. How we achieved? 50 rupees obtained for 100 rupees. So therefore, into 100%, it will be how much profit percentage? Rate of return, 50%. And the next year, we purchase at 150 and we sell it 100. Then this time, loss of 50. So this time, how much loss? The percentage of loss? 150. 150 for that price we purchased. And the loss here minus 50. Then tell me how much, what's the rate of return? Tell me quickly. 50 over 150. How much? 30% something. No, it is 30%. Looks 30%. Right. 1 over not 30% actually. 1333. 50 minus 50 divided by 150. It should be 0.33. Right? It should be 0.333. So therefore 33% something. Out. Now let us calculate the average rate of return. How much average rate of return? So there are returns we have 50 plus 50% plus 33.33%. And there are two observations. So that 83.33 by 2 it's like 41 point something, 41.75 something, right? So this is the average return when we use arithmetic mean. But actually, in reality, this is not wrong. This is not correct one. Why? Initially, we purchase 100 and price go up and again go down. So when you look at the price, 100 rupees at the beginning, ending 100. So the gap, so the 100, same 100. So therefore, no profit, no loss actually. And no profit, no loss. So how we can say, in this instance, how we can say the average profit we obtain 41.7, 41.5 something like that. How? And it is inappropriate, right? It is inappropriate method. It is inappropriate method of calculating return, right? So that in these instances, we can apply a different formula that is called geometric mean. Geometric mean. How to calculate? You know, the first time the return, first instance return 50%. So therefore, we can take 1 plus 0.5 5 into 1 minus 0.33, like that, 33.33%. And here, how many observations? How many observation? 2 and minus 1. So I will explain the formula later. And when we calculate this, so we can find this is 1.5 into this is 0.677, like that. And we find the root, square root, and minus 1. So so what is the answer? What is the answer of this? 1.5 plus 1.5 plus 0. So not plus, actually. 1.5 into, I take Excel file, right? I take Excel. Excel file. Then here, the first return, 50% first return plus, so actually 0.5, 0.5, and minus 0.3333. Right. So that what we take here equal, right, equal 1 plus this value into 1 plus this value, and we get 1.005. And then we take square root of this value, 1.0, then minus 1. So almost it is 0, 0, 0, 0, like that. You see, when you can see, scientific numbers, right? You see profit, see the profit rate, almost 0, right? Almost 0. But when we apply the arithmetic mean, it shows 41 something profit, 41 something. So that the arithmetic mean always will not give us the correct meaning. So right here it shows almost 0. Here 0, almost 0% return. So therefore, arithmetic mean for these instances cannot applicable. So therefore, the geometric mean has been introduced. Right. Now let us calculate the geometric mean of this data set. Here we simply this is the formula to calculate arithmetic mean. Here x1 into x2 into x3, like that. And if there are xn observation, then we have to put n. So this is geometric mean. This is the standard formula, right? Accordingly, we can calculate geometric mean for this 3 into 8 into 9 and root of 1, 2, 3. There are 3 observations. Then we can find 3 into 8 into 9. So there will be how much? 389. 3. So they have converted into index numbers. But you can apply, right? You can directly apply. Then you can find the answer. 2 into 3, 289. here 3, 8, 9. At 216, and we can find the square root. So no, not square root actually. To the power, we can take the power, right? Power 1/3. Then we can get 6, right? We can get the value 6. It should be 6. Here we can use in this method as well index numbers. Here 3 we can write as 3, and 8 we can write 2 into 2 into 2. So therefore 2 into, yeah, right, cube, like that they have written. And here 9, 3 into 3, 3, 3, right? So therefore like this, this 3 here, and this 8 here, and the 9 is there. So here when you look at here, you can see 2s and 3s. Here 1, 2, 3, and 1, 2, 3. So therefore they write 2 to the cube and 3 into cube. So square, so 1 over, so square 1, 3 in this one, no, 3. Cubic root. Cubic root we can write like this. So that then they can cut this, and 2 into 3, 6. This thing you might study it in business mathematics in your first semester. Likewise, we can calculate the geometric mean of this 20 into 30 into 36 into 40. And how many observations? 1, 2, 3, 4 observations. There are 4 observations, so that we can calculate. So there are, they have used the log method. Here 20, 30, 36, 40. This is the original form. And then they bring this 4 here. 1 over 4, root of 4. And convert into the log value, right? Log. So when they transform into log, right? Log, this this value come here. The log 20 plus log 30 plus log 36 plus log 40. And then we take the value of log 20, value is this, and log, right? Like that, if we take all together, we can get the log value is this, and 1/4. So that we get 1.4841. And so this is the log form, no? This is log form. When we convert in the normal form, so we apply anti-log. So anti-log of this will be 30.48. So the things you studied, the log and indexes in your business mathematics may apply. Otherwise, you can use calculator as well, no issue. So the use of calculator is allowed in your examination, but you have to write the steps very clearly and neat. Right? We apply this in the Excel 20, 30. Here 20 observations, 20, 30, 46, 36, 40. So that we can get here 20 into 30 into 36 into 40. That we can take this value, and we will find 1/4. So there are 4 observations. 30.488. 30.488. right? So this is the answer. Geometric mean. Geometric mean is useful when averaging ratios. We use what? The rate of percentage. We use percentage of return and rate of increases, averaging ratios. For that, remember, we should apply the geometric mean for these instances. Very careful. You should know when we apply the geometric mean. Here, this is very illustrative question, right? Illustrative figure. The problem: calculate the geometric mean. Assume that, so there are three cubes, right? There are three cubes. This one 3, and this one 8, this one 9. When we get all these three cubes, then what is the exact average size of the cube? So one cube 3, one another cube 8, one. So when we take this 3 and we need 1, right? Average that we want 3 equal 3 size, equal size 3, right? Equal size 3. So in this instances, when we apply 3 plus 8 plus 9 and divided by 3, it will not give us a correct answer. If we apply geometric mean, right? Geometric mean, it will give us a correct answer. This is the formula for the geometric mean. Yeah, perfect cube side will be 6. Essential for averaging percentage, financial portfolios, and compounding growth. You should remember this. And harmonic mean, the next one. So harmonic mean, when we have the reciprocal mean, here reciprocal symbol is this. So 5, reciprocal of 5, 1 over 5. This is called reciprocal. The reciprocal of the mean of the reciprocals. Harmonic mean, this is balancer of rates. We apply this harmonic mean to find the averages of the rates. The reciprocal of the mean of the reciprocals. Here, right? Here, this is here the set of numbers, right? The first observation x1, x2, x3 up to xn. If the harmonic mean is h, when we consider harmonic mean, we write harmonic mean like this, geometric mean like this, and arithmetic mean like this. We write in this form, right? So harmonic mean, if we consider the harmonic mean h, right, then this is reciprocal of harmonic mean is equal to the mean of reciprocal of the given numbers. So we have to find out reciprocals of reciprocal of the mean, right? We have to find in this way. And it should be n, right? It should be n. So this is the formula, right? So first we have to calculate, for example, 2, 3. If you want to calculate the harmonic mean, so what we have to do is, here we have to take reciprocal. We have to convert into reciprocal. Reciprocal mean this value, reciprocal for this value 1 over 2, and reciprocal of this 1 over 3, right? So that harmonic mean, right, equal, how many observation? 1, 2. There are 2 observations. So if we convert this, so this is 1 over h, no? This is 1 over h. And h equal 2 over 2 into and 1 over 3. So that we will get H equal harmonic mean. Right? So this is the way, this is the formula. The simple form, right? The simple form of harmonic mean is this. So you just remember this formula. No need to bring this kind of these steps. So this is for illustration purpose. This is the final formula. Here we take reciprocals. Here reciprocals. So it may confuse you. So you can remember this formula only. That is enough. Harmonic mean equal number of observation over reciprocal of the values. So what are the use cases? We may use this one. It may suitable for to find the speed. Find the speed. Speed mean the distance is constant, right? The distance is constant. For example, A to B. Time varies, right? Mr. X, right? Mr. X travels from X to B, X to A point to B point. He take 2 hours. The first A to B, and B to A. He travels in 4 hours. Then what's the speed? What's the speed? Average speed. So what our people say? 2 hours plus 4 hours divided by 2. Then 6. So there are 3 hours. So this is the answer many students will write. But actually, we can apply this arithmetic mean to find out the average speed. Here the distance same, but time varies. Purchasing budget is constant, but unit vary. For example, first instance you purchase, you spend 100 rupees to buy 50 items. Now you purchase for same 100 rupees, you purchase 42 items. So this time, what's the average rate of a unit? This time also we have to use harmonic mean, right? We can apply a formula, right? Here an example is given. A driver travels from city A to city B, right? A, B, city A to B. The speed of 20 kilometers, 20 kilometer per hour. On his return journey from B to A, he travels at the speed of 60 kilometers per hour. Find the average speed of the driver the whole journey. Or people say what? 20 plus 40 then equal 30 kilometers per hour. This is what? The traditional answer. Not actually 60, no? 60. So they have 80, 40 kilometers per hour. This is how many students try to answer. But it's actually, it is inappropriate. It is inappropriate. You see, why we can say inappropriate? I give you one of the basic science. You might study it in science, how to calculate the speed formula, distance divided by time. This is the formula to find out the speed. For example, in this case, point A to point B, assume it's a 60 kilometers. The distance is 60 kilometer. A to B is a 60 kilometer. And for 6 kilometer, if he travels 20 kilometer per hour, how long it takes? A to B. If a driver travels 20 kilometer per hour, how long it takes to arrive point B from A? How many hours?
3 hours.
3 hours. Very good. 3 hours. And if the same driver from point B to point A, he travels 60 kilometer per hour, how many hours? How long it takes? He drive the vehicle 60 kilometers per hour.
1 hour.
1 hour. Very good. 1 hour. Right? The distance is what? Distance, total distance, A to B, 60 kilometers, and B to A, 60 kilometers. Time, 3 hours and 1 hour. 120 divided by 4. It should be 30 kilometer per hour. 30 kilometer per hour. But you said here, earlier you said 20 kilometer here, 20 kilometer per hour plus 60 kilometer per hour divided by 2. Then 40 kilometer per hour. Here, what is right, what is wrong? $30 or $40, which is correct one? Which is correct one? In science, what you studied? Scientifically, 30 kilometer per hour or 40 kilometer per hour? Which one is the correct one? Correct approach?
30 kilometers.
30 kilometer. But when we apply arithmetic mean, we will find 30 kilometer. It's wrong. And also here we don't know the distance in the question, right? In the question, they didn't give us the distance. The driver travels city A to B at the speed of 20 kilometer per hour. On his return journey, he travels at the speed of 60 kilometer per hour. Find out the average speed. Here, the distance between A and B is not given. The distance is not given, but they given just, and also they are not give us the how many hours they traveled. The time also not given. Time also not given. So this instances, how we can find the average speed? As a solution for this kind of problem, they have used what? Harmonic mean. Harmonic mean. So when we apply harmonic mean, here, first one 20 kilometer per hour, no? 20 kilometer and 60 kilometer per hour. Reciprocal of this 20, 1 over 20. This is reciprocal 1 over 60. Harmonic mean, we know that the formula. So there are two observations and 1 over 20 plus 1 over 60. Then what is the answer? What is the answer? Can you solve this? Can you solve this?
Thirty kilometers.
Okay. 1 over 20. 1 divided by 20. One over 20 and 1 divided by 60. 1 divided by 60. Right? Then there are two observations. Two observation should be divided by this value plus this value. Yeah, 30 kilometer per hour. Right? 30 kilometer per hour. That is the answer. This is what reciprocal of harmonic mean. They write reciprocal. So if we cut if so this is 1 over h, no, reciprocal. Reciprocal of this reciprocal h over 1 equal 2 over 1 over 20 plus 1 over 60. So that we can get 30 kilometer per hour. Right? Clear? Clear? You see this one? You see the slide? The speed trap. Why the average of 20 and 60 is not 40? A driver travels from city A to B 20 km per hour and return 60 km per hour. So this is the point. First, this is the first travel A to B, right? Time spent A to B 20 km per hour. For example, 3 times of this. Here, 1 units. So altogether four distances of total time, right? For example, 3 hours. This is 1 hour. Altogether 4 hours. Out of 4, this is 1/4, 25% of the time. 20% of the time. Here, balance 75% of the time. This is first leg. This is second leg. Mean the first travel and second travel. Arithmetic mean, right? 20 plus 60 over 20 over 2 equal 40 kilometers per hour. This is incorrect. So correct way, n over reciprocal of this average of this, and we get 30 kilometer per hour. This is correct. The slow speed dominates the timeline, pulling the average down. Right here, the first, right, he brings a lot of load, so therefore he travels 20 kilometer per hour. It takes a lot of time. Here in this, right, on the return journey, no load or small load, so that he managed, and then he brings the items very quickly. Therefore, it takes very little time. So the rule of thumb is when one element is constant, we can use harmonic mean, especially for speed and some budget constraint, especially for rates. Budget constraint, let's see one example. Harmonic mean for a set of numbers x1, x2, x3. If the harmonic mean is h, then 1 over h, reciprocal of h is equal to the mean of reciprocal of given numbers. So these are the reciprocals of given number. And the average of reciprocal is reciprocal of the harmonic mean. So that is the explanation is given. So you can remember this formula and find the harmonic mean. Find the harmonic mean of the numbers. See how 4, 8, 4 plus 8 plus 9 plus 12. So simply we take the reciprocals 1 over 1 over 8, 1 over 9, 1 over 12. And how many observations? 1, 2, 3, 4. There are 4 observations. Then this is equal harmonic mean. Very simple. Very simple. You can get the answer. Write a distance. Now look. Now read this question. Read this question. Here, budget is constrained. But same budget, he purchased nails. Nails mean the pin, right? Pin. Carpenter normally purchased these pins. Carpenter spent 200 1 month for nail costing 40 per carton. Carton means a pin box. A pin box per carton 40 rupees. 40 rupees, right? But he spent 200 rupees to buy this. How many he purchased? A carton box, 40 rupees. He allocated 200 rupees to purchase. How much per unit of carton? A box, how much? So how many bottles, how many box he purchased?
5.
5, very good. 5 units. Then second, and another month, in the another 200 rupees in the next month for the same kind of nails costing 60 per carton, right? The next time he spent 200 rupees, but he a box of the carton 60 rupees. Then how many cartons he purchased? How many units?
3.
3 point something, no? 3 point something, right? Not 3 actually. How much did he pay per carton on average of the he purchased nail? The question, what is the average cost? Average cost per carton. Question is average price per carton. So normally, how do you find the first time 40, second time 60 divided by 2. Then how much? 100
50.
equal 50. Is correct? Is correct?
No.
No. Why is that? Here, budget is constraint. Budget is constant, not constant. Budget is constant. Constant mean not change. Budget is not changed. So therefore, we need to take the harmonic mean. Here 1 over 40 plus 1 over 60 n. Harmonic mean. N equal 2. Can you solve this? Can you solve quickly?
48.
48. 48. So earlier you said 50, but actually it should be 48. 48. That's the correct way of calculating thing. In this problem, the average cost is the harmonic mean of the given rupees 40 and 60. Since the same amount, right? Since the same constant amount is paid both items. If the harmonic mean is h equal 1 over 40, then we get harmonic mean 48. You see, 48. And how much he spent? He spent 400. He spent 400. Average box. How much average box? 48. Then how many boxes he purchased? How many boxes he purchased? We can easily find using this way.
8
Yes.
point something. So
Yes. Okay, this is about harmonic mean. Okay, now in the next class we will discuss positional values at quartiles, quartiles and percentiles. We will discuss in the next class. And also the summary of this framework what we studied. We use arithmetic mean. Simply we use arithmetic mean here. Arithmetic mean. Find typical values. Right? Our goal is to find the typical traditional values. If there is no outliers, outliers mean extreme values. If there is no outliers, we can apply mean. If there are outliers, extreme values, like in the previous example, the shop textiles sales revenue. Out of 5 shops, 4 shops made purchase below 50,000, below $5,000 per month, but particular one shop they did 18,000. So when we apply arithmetic mean, it may mislead because one extreme value may mislead. So if there are outliers, extreme values, the mean value may not represent the central location. So therefore we have to apply median. Sometimes we may use mod. And right, in most popular one, to find out our goal is to find the most popular one, we may apply mod. To find out average growth rate, we may use geometric mean. Average speed or cost, we may use harmonic mean. Right, harmonic mean. So that's what today's session is about. The next class we will start from the central location, not measure of central location, positional values, fractiles, sometimes called positional values. Positional values with fractiles. Any questions? We can stop the class now. Do you have any questions?